Hola, yeah, good morning. It's a pleasure to be here. This is an overview talk of what can we expect from upcoming Java 9. There are about 82 Java enhancement proposals right now targeted and scheduled. So if I were to talk through all of them, just mention them, it'll take an entire hour. So I'm going to talk about a few of those, I guess, the most important ones. And there will be lots and lots of links and pointers. And if you're interested in a particular topic, click those and follow along. So this is an overview talk. Nothing too difficult, nothing too deep. But let's go. So I'm talking about this now because, as you will see in the review slides, some of the changes are going to be breaking changes. Some of the changes will make it difficult, perhaps, to test application with Java 9 in your test environment, and it takes time to come up to work around those difficulties, and therefore it's a good idea to prepare yourself in advance and start playing with early access builds that are available now. And I work for a company called Azul Systems. We actually make compatible JDKs, and we ship, so we support Java 8 right now, and once Java 9 is out of the doors, we'll have to deliver our own our own version that will support Java 9 as well, and therefore we started planning on it early, and that's how I got interested in this topic. But I'm a sort of a sideway observer of the process. I'm not directly involved in. I used only public sources to compose this presentation for you. The community has been following along as Java was developing, and just a couple of quotes. There's a guy from Apache community, Uwe Schneider, and I saw his tweet about a couple months ago. He said, "Oh, look, Java 1008 brought pretty much any project use and builds." Apparently, there was a problem with the multiple release jar feature that's coming in, and it was fixed like in the next build, so no problem there. But like 2 weeks later, he said, "No again. The Gradle is broken." And that was fixed later on, but that's how community works. Oracle prepares early builds, people test, find deficiencies, those are fixed, and that's how it goes. There are quite a few breaking API changes, and some good projects compose and maintain lists of those incompatible and breaking changes, the moved APIs. NetBeans is an example of such a good project. There is a page. This is the URL. It's actually a very long list. I'm just giving a screenshot of the top of that page, where you can look at where you can find the changes that were relevant to that project. It's not meant to be a complete. It's just the one that matters to them. But nevertheless, it's a good idea to go through this through this page and perhaps build your own one, which will matter your project. Things keep coming. For example, a couple weeks ago, a guy named David Lloyd from Red Hat said, well, the tools like Maven and JUnit, I have difficult times working with the way that modules are declared in the module info Java file. It has been, people have been ranting about it for the last 5 years, and still those issues are not quite addressed. This guy is very concerned. So a lot of people are sending messages like this to developer lists. There is a high-level concern, but does it mean that those changes that are coming in 9 are bad, or should they be not happening? Well, my take on this is that there are only 2 kinds of languages, and this is a fairly famous quote, the one that people complain about and the ones that nobody uses. And this quote comes from Björn Stroustrup, the man behind C++ language, who has been taking punches for decades for all the changes that were happening in C++, and yet C++ is probably the second most popular language in the world right now, perhaps after Java. So I'm pretty sure that Mark Reinhold and those guys at Oracle will be taking punches for the things that we'll be doing in Java 9, but the only way to advance the language and the platform is to make some people unhappy, and that's just the way it goes. Let's do the check on the Java timeline. So this is a schedule. There was a long delay between 6 and 7, partly due to difficulties that were within the Sun, and that was later acquired by Oracle. Java 8 came 3 years after Surge 7, and what we can expect now is almost the same 3 months will be between 3 years between Java 8 and Java 9. However, what I find even more important is the end of life time frame. As you can see, we already passed 1 year past end of life for Java 7, and Java 8, once it goes out of the door, in another year, Java 8 will go to end of life. And so let's talk about what it means to you. Suppose you have a project. Let's say you're running an application on Java 7, and you're responsible for keeping that that setup secure. And vulnerabilities keep being discovered. I don't know if you follow any of that on the Register or some other websites. Every quarter, Oracle releases security updates, and those are not empty. There are vulnerabilities that keep coming. And so if in order to stay secure, well, you need updates, right? And where they can come from, once end of life period is there, you can no longer get them for free for, let's say, Java 7 now, or in 2017, it will be for Java 8 as well. The options are either to sign a support contract with one of the vendors. Oracle is probably the biggest vendor there, but there's several more. You can adopt OpenJDK. There's ICE-T build that Red Hat prepares. We make Azul builds for many platforms, and a lot of companies do homebrew builds. They build Java OpenJDK themselves, and not necessarily small shops, but actually the giants of the industry, of the IT industry, pretty much all the big names that you can name. They all have their own homebrew builds based on OpenJDK. And the third option will be to migrate to the latest and greatest JDK. So if the first two are not an option for your business for any reason, you might as well be forced to move to Java 9 whether you want it or not. So it's a good idea to prepare for it. A little bit in-depth look at the schedule. In a week, well, actually next Thursday, there is an expected release of the feature complete version. So next Thursday, you'll be able to download what is declared as feature complete. There will be multiple rundowns, but the ones we care about, the feature complete and probably general availability, which is coming up next year. So less than a year to go. Well, let's refresh real quickly with just one slide on what was good in Java 8. How many of you have tried lambdas anywhere in production, at home, in tests? Okay, quite a few. Good. And how many of you have tried stream APIs? Okay. Well, if you have not raised your hand twice, it's a good idea to go and refresh, because those are, in my opinion, those are the key features of Java 8. There are lots of articles right by now and books on Java 8, but here is one that comes from Oracle that picks all the changes that has happened in Java 8, and Java 9 is built on top of that. So, how do features? Where do they get the ideas? How do they become part of the language specification and the implementation? OpenJDK is a project governed by processes, and one such process is a Java Enhancement Proposal, or JEP. So I'll be mentioning many times JEP's XYZ. It actually follows kind of this process, and if things go well, it kind of, I'll click through. So if things go well, it just goes through stages, but the proposal can be withdrawn at some time. But if you're interested in a particular feature, you can find it on the web and on the OpenJDK website and see where it is. And by feature complete release, it should be in the integrated state at least. Otherwise, it will be dropped. And for other features, they may be like in proposed state, which means may or may not land in the next release. There is a similar yet an older process called JSR, which predates JEP, and it's a bit more formal and rigorous process, which involves multiple votes that happen along the way. I will not go very much into details how those differ, but just to mention that some features or some language changes are governed by JSRs, XYZ, but most features are governed by JEPs. So that was my brief introduction to this talk. And now let's talk about the key ones. And the feature driver for Java 9 is modularity in Java modules. So let's spend a little time on understanding what are Java modules. Let's talk a little bit about code encapsulation. When we code, we typically operate on fields, and we code in methods. Those are wrapped into classes, or it can be abstract classes or interfaces. All three of these are called Java types by the language specification. And since Java 1.0, those could be placed optional, could be placed into packages. So this has been the world until Java 9, and Java 9 introduced a new layer called modules. Modules operate on packages. Packages operate on Java types. So there is a very clear inclusion model there. So why was it needed? Why do we need another layer on top of things? Well, one of the reasons is that JDK was getting bigger and bigger. Java just celebrated 20 years. Features are being added. It's a giant monolithic runtime and JDK, and there was a need to separate to be able to ship custom size rise times just for the features that are needed from any specific for specific applications. For example, some folks might be using might be writing desktop applications that don't need Corby features, or you can name multiple pieces of JDK, which not all of them are needed as every single application. Profiles that were introduced in Java 8, profiles 1, 2, and 3, address this problem very much partially, and as you will see in a few slides, with modules, the customization of JRE becomes way more comprehensive and way more customizable. The other problem is the famous jar class plus hell. How many of you have been bit by the fact that the same class was defined twice, and if you reorder jars in you get a different definition that you're using? Okay, I see quite a few hands. Thank you. It's actually almost the entire room. So you guys know maybe even better than I do about what it means. So the dependencies can also be optional. Depending on the scenario that your application is running, dependencies are transitive. Lazy class initialization brings its own hardness. You can easily get a no class def found error in the production, which could not be for some reason be found in a testing environment. And the visibility problem. So the way that visibility attributes are applied is that whatever escapes a package must be public. And this creates a security hole, so other packages, even from different class loaders, can see those public types and public methods and members. And since Java 1.1, there is a security manager mechanism which prevents you from doing that. But the problem with security manager is that it's a security mechanism that's off by default. You need to think about it. You need to enable it. That's not generally how security works. You need to have something on by default. So modularity is running in a project called Jigsaw, and it naturally falls into two parts. One part is the language changes and the rules and the visibility, and the other part is how those rules and how that new concept is applied to JDK itself. So on the left side in Java modules, we have a JSR 376, which defines what modules are, and JOTB16 sort of extends of that JSR, covers it, but extends more to things that are not covered by JSR, not covered by the language specification, and I'll be referring to that JEP a lot. On the right-hand side, that's how those concepts were applied to class libraries, and how the whole big monolithic giant JDK was partitioned into multiple modules, and what kind of dependencies were declared. Well, let's look at a pretty simple example. Not more complex than the whole world. We have a a location provider, and it just returns a static a static method that returns a string, and it's placed in a package called services. So although it's called service, it's nothing to do with SPI, it's just the name. And on the right hand side, we have a module, a package called presentation, with class module demos, public static main that calls the guy on the left, and returns I'm at J on the beach. So this is a pretty simple example. You can run it with java.10, I guess. And but the one thing that's missing here is the implicit dependency that the guy on the right depends on the right of the guy on the left, and the guy on the left actually exports this functionality. Now it's public class and it's a public method to the guy on the right. So let's say we want to put this into modules and declare this dependency. By convention, packages that are defined by a certain module are placed in a directory. So in this case, I have a top level directory as module and package services inside of that. And at the top level, by convention, that's governed by the standard. There's a file called module.info.java, which defines the module S, and it declares the characteristics of this module. So in this particular case, it just exports package called services to anybody who requires this module. Why is it module info.java? Why not XML? Why not JSON? Why not something else? Well, it's the language designers just thought that this is the format that they control. So even though it's called .java, it actually has nothing to do with, or very little to do with the regular Java files. And on the right, we have a declaration of a second module, and which just says, well, I'm module P and I require module S. So there is a simple relationship that the simplest relationship you can imagine. All right. So what are the new parameters? So to compile this example, well, you could compile it without modules, but if you're doing it in a modular way, you would specify module source path, which is the path to the roots of where modules are being searched. Now, because I've specified this module source path, the Java compiler will not only compile this guy, but will also walk upwards and find the Java module info file and compile that one. And since I actually use this module source path, I'm now required to use the -d option. And after running this command, you will see two class files: one for the location provider class, and one for the module definition. It will also be compiled into .class file. So the second guy, pretty much the same command line, but now I want to specify that. Let's say I don't have the sources of the log provider, but I only have the compiled one. So the module path is where it will look for compiled modules, and the verse is pretty much the same. And so this will compile the second module. This is a way to compile so-called inflated modules. These are not packed yet. I will talk about packaging just in a second. And to run that, you specify the module path where to find modules. You specify what module to run and what's the class in that module and in which package you want to declare as a main. So far pretty simple. The jar files were expanded to support modules, and those are called modular jar files. So this is how you create a modular jar file with commands like this. So in the second line, you will notice that you can specify the main class, which would be called associated with this module jar, and then your invocation line becomes a little bit simpler. So you just specify the module path, and then the module will know that it needs to find public static main in this guy. So this is the module jar. There's also another file called jmod, which is another form of storing modules. I'll not go into that today, but feel free to ask me at Q&A part. Well, let's look at a bit more verbose example. So this is a real one. This is taken from the lang tools of JDK9. And I'm picking this one just to show some of the syntax that is present there. So you can see it requires, we saw this in a previous example, but here's a modifier called public. So the public read modifier does the following. So suppose this Java compiler, it provides modules and classes, and in somewhere in the methods, there in a signature, there is a class which is defined in some other module. So Java compiler would require that other third module, and in here I would need to list all of those dependencies, separated by commas. Instead of that, this public modifier creates this transitive closure so that I don't have to specify all of those at once. Exports, we've seen this in our Hello World-like example, but now in this example, the doclint package is exported to a specific module and nobody else. Means nobody else except for JDK Java doc class can see this this module. I'm sorry, this package. Then there are keywords like uses and provides, which are related to SPI. This says that this module and some class within this module uses a service provider, processor, and it also provides services for a service platform provider with a specific provider called JDK platform provider. So this, strictly speaking, this is not mandatory. This could be declared all the way in meta-inf services, but in order to enable ahead-of-time compilation and some other features, it's worthwhile to hoist this dependencies, this SPI dependencies into the declaration of a module. All right. So your natural question will be, well, I don't know anything about modules. I know that JDK 9 will be modular. My code is not modular yet. Can class path, the old one, coexist with modules? Well, the answer is yes, but there are complicated rules. So first of all, whatever you put in the -cp will be declared in the so-called unnamed module. And unnamed modules can named modules. So all JDK classes are now in named modules, and your code is likely to be in unnamed module. You can access those for free. There's no need to explicitly declare it yet. The reverse isn't true. So if you already, let's say, started writing module and you want to access something that is not modularized yet, you cannot rely by default that those will be visible. But there is a way. You can place, let's say, a jar file of that old legacy old code into a module path via -mp. This will be automatically turned into a module, and the name of that module will be like the name of the jar file. So this is an automatic way. These are called auto modules, and this is really your transition path. So you have multiple jars. You can start working on modularizing one of those and put the rest on this into this MP path and make them auto modules, so that you can refer to them in your build scripts and your launch scripts and so forth. So this is the transition path. But I should mention that unnamed modules are being searched at the last option. So module path and modules are searched first, and then as the last resort, types are being searched in unnamed. And this creates some difficulties. For example, a package can be declared only in one module. So if you have multiple jars declaring parts of the same package, this may not automatically work. But there are ways to get around it. Well, I said in the previous slide that unnamed modules can access all named modules. That is not so true as of 2 weeks ago. And these particular 6 modules that are listed here are not, this is a part of the JDK module system, are not automatically searched, are not visible from unnamed modules. You can still overcome this by add mods command line for your Java launcher, but still need to do that. And there are more details if you're interested in this topic. There's an email from Alan Bateman that was like of this Tuesday, and more details will be in JOTB16. As of now, it's still not updated, but it's going to be updated really shortly. It's a work in progress, like I said. So this is the latest. Okay, so just sort of to make things a little more clear, or to recap, so there are named modules like the one that in the very first example. There are automatic modules. Those are the jars that you compiled before, without any notion of modules, but you place them on the module path. So those are auto modules. And there is an unnamed module. Well, there are unnamed modules. Actually, there's one associated with each class loader. And that's basically your legacy code. So if you started to modularize your code, you might find a useful JDEPs tool, and there is a special flag called gen module info. It will basically take your jar and generate a file like this. It will basically find all the requirements that are present, and it will declare every package that's in that jar as an export. And then you can manually go through this list and see which ones are really private to your module and which ones you want to export further to the world. Or we may want to export to some specific module, not to everybody. So that's your tool to help you go modular from the existing code. There is an option that's present in 8 already called JDK internals, which allows you to look for all the internal APIs that your code might be using, and you might want to revisit that. That's your first source along with that NetBeans page that I mentioned in the beginning. That's one of the ways that you'll search for incompatibilities in your code, that the possible breaking changes that will happen with 9. There are lots of things that you can sort of overcome. There are a lot of flags that you can sort of overcome the default module vision access model. And one of those is add exports. So if there was an export that was missing at the time of compilation before the launch, in your launch script, you can add additional exports. For example, in this case, this is a private package, but it's now exported to all unnamed modules, and those can access it. So it's a sort of a way to help you, but it's also a way to. But it's also very indicative that you probably have some sort of a problem, like using internal API, and you might want to revisit that code and seek for replacement for public API instead of a private API. Well, there's something called layers, which is a bit more complicated. I probably should not go into very much detail. Just want to mention that until you start messing with, until you start doing like an application with plug-in interface where you can plug in code that requires different modules, maybe different versions of modules, you'll most likely work just with the boot layer, and that will be sufficient. And this the new layers create a whole new universe of modules. So I'll just kind of skip through. So this was a little intro on the syntax and visibility that is declared by modules. Now let's look at how this was implemented in JDK as a whole. So at different times over the past 10 years, the authors of this modularity were taking pictures, and this is like the dependency graph within packages of at the time of JDK 7. So that was I don't know, 8 years ago or so. As they were working on making those requirements and those requirements more clear, things were simplifying, and this is the modern graph. What is really neat about it is that if you can take any subgraph, and if it has no edges going out of that subgraph, that is a valid JRE that can be shipped. It can be built and it can be shipped to a customer, or can accompany your application. And so this allows you not just like profile 1, 2, 3, but it can you can build your own custom JRE, or you can even embed your own code, your own module, and ship that if you're based on OpenJDK. There are a couple of more sources that you might want to read. And yeah, there are many more things to discover. That the whole topic is pretty big. Ryan Krylov and his team were giving 5 talks at Java 1 and then FOSDEM, so 5 full hours. There's no way I can cover that much. There are things that you might want to read about: how reflection supports module, what is a multi-release jar. It's a new jar format that allows you to place into a single jar code that is required that can run on JDK 7 and 8, and there will be 9. I touched a little bit on layers. Look at JDEPS-help to see what other features that JDEPS provides. And I should say that IDE has been following along this project, and the support in NetBeans and Eclipse is pretty good right now for modules. So if you download the latest, at least these nightly builds, they should be pretty much up to date. These are the hashtags, and probably the most interesting resource is this URL, which really lists all the unresolved. That URL, the text on that URL explains all the unresolved and things that people at the Jigsaw community are still debating about. So that's your resource for the questions you may find still unanswered. Maybe somebody else already just stumbled on those. So if there's one thing you want to remember about modules from today's talk, modules are all about declaring dependencies between different parts of code, and the rest is just really the details. OSGI has been a part of this process. There is a member of OSGI on the Jigsaw expert group, and the way I understand it is that OSGI is compatible and complementary to modules. Modules will provide a lot of optimization paths. So, for example, now with modules, it's possible to declare that some type does not escape a module, and therefore some additional optimizations will be possible and will be implemented in future. So we can think of modules also as as a performance feature. I already talked a little bit about the compatibility with existing code that's in ClassPath. Jigsaw had several restarts, and for example, in some of the initial versions, there was support for versioning. So, for example, you could say module A version 2 depends on module B version 4, and not less of version 4. That's no longer true. That is believed now to be tracked by package managers, perhaps by OSGI, but not by Java modules themselves. You can declare a version of a module, but the version is not verified by the runtime. There are more links. For example, if you want to, you want to have an in-depth look at Java modules, you can watch the 5 hours of Java 1 and Devox Belgium presentations given by Oracle people. The code is already in the main trunk, so it's there. And in 5 days there will be a feature complete version. And these are a couple more articles you might find interesting. At least I use those as part of the talk. This was the introduction into modules. Now let's move on to syntax, language changes. Everybody asks, what are the cool things that are coming into the language? Well, not many, and those are covered pretty much by the milling project coin. Just 5 of those. So one thing is that you remember in Java 8 introduced private methods, but there was a little problem with private methods. For example, you had a default implementation in interface for method A and B that shared some common code. Now, you could hoist that common code into some code C, but maybe that code doesn't make sense as part of the interface. You wanted to hide that hoisted shared code C. It was not possible with Java 8. With Java 9, you can declare a private. So this private method C would be visible to A and B, but would not be visible to the implementers of the interface. So these are the do's and the don'ts for the private methods. All right, let's move on. Try with resources and effectively final variables. So in the past, you would have to declare your resource here, right here in the or define your resource right here in the try block. With Java 9, it's possible to hoist it out and make your code a bit more readable. and the runtime will verify that this is effectively final. So the two are actually equivalent. In 80, this would be an error. Then the safe-RR annotation. I'm sorry. It used to be available for static and final methods, and now it's available for private methods as well. The problem with those annotations is that when you subclass, the annotations propagate with the class, but not on a per method basis. And that's why the annotations like safe-RRs are not available for all methods, but only for the ones that cannot be overloaded in the subclass. All right. So here's a common pattern. For example, you have a double braces initialization, which is quite commonly used here. And people have been screaming about this guy saying, "Well, this is redundant. Can't this be reduced from the inner class?" And prior to 9, you would get a compilation error like that. But in Java 9, you can just use the diamond for that, and save a little bit on typing. So prior to 9, this would be a compilation error. A very minor neat that used to be possible to use underscore as a local variable. Now it's a warning in Java 8, and it's not allowed in Java 9. So these are all the language changes I could find so far. There is a proposed API, feature of using type deduction and allow you to do things like in C# you can declare var variable equals the return of a certain method, or in C++ you can do auto variable equals. So that is still in proposed state. That's not targeted, therefore I don't have a slide for it. But if that happens in Java 9 timeframe, then you will have it. But some people argue that that's not really necessary and will reduce the readability of code. Quite a few APIs are being updated. I've picked the process API. Yesterday there was a talk in Java Unsafe and listed a few examples of how you can get the PID. But in any case, that would require some sort of a call into outside. Like in this example, I'm calling the shell and grabbing for the PID that the shell returns. And not only this is very verbose, but also it's error prone, because if you're running on Windows, what do you get here? But in Java 9 with the process API, you can just get current process and get a PID from it, and no need to call into native in any form. The API can do actually more. It can list process, trees of process can operate on those. So it's a nice update for the process API. Spin loop hit is something that I've been personally a part of. It was the Java part was done by our CTO, and I did the hotspot implementation part along with another fellow from our company. So what it does is really it's targeting the low latency market and people who are striving for low latency in their application, and to a less extent, but also to some extent, performance. What it really does, it adds a new method into Java lang thread class. The method is called onSpeedWait, and it's really just a hint. You don't change any functionality by adding that method, and some implementations can just do a NOP instead of a call to that method, which is okay. But on x86, this will translate into a pause instruction, which various researchers show that it's fairly beneficial. So this is how you use this. So for example, you have a spin wait loop here, and you just call a method here. Again, nothing changes if you don't do this, but like in terms of functionality, but the performance can be quite different. So here is an example, and this is a JMH benchmark, and it's running a producer and consumer, and measures time that it takes for a message to go from producer to consumer. So this horizontal line is how much text takes to actually to execute system nano time. and this guy on the top is without spin loop hint, and this is with spin loop hint. So, and this is actually measuring latency of a message being passed. So, so it can be beneficial. I mean, this example is sort of artificially crafted, but there is a noticeable difference. The guys in the C++ world have been using the pause instruction for a while now. There is a way to sort of to write a code that you can place the spin loop hint in your code even if you're still compiling for Java 8. And such example is it can be found in the Agrona library. And here is a link. It basically uses a method handle trick. So you can place the call to the Agrona library on speed wait, and we'll dispatch it over to actual on speed wait in case you're running on Java 9, or we'll dispatch it to nothing in case you're running on Java 8 or prior to that. So check out this link if you're interested. There is another feature in Java 9 called JShell, which is really a REPL read, evaluate, print loop. Very probably you know from other languages, but now it comes to Java 9. And really, it serves primarily the purpose of teaching Java. So if any of you teach Java to somebody else, we'll usually start with a hello world. And when you run hello world, you have to explain all the various syntax details that are present in the hello world. It's not very logical to start, teaching Java in that way. I don't have time to do the JShell demo, but basically in JShell you could just execute, with the print line, or you can teach streams, or you could teach lambdas in a very simple form. So it makes teaching Java way more logical, and also it's a way to quickly check the syntax before actually coding into your application. So like in my machine, I have a lot of hello world-like code where I actually test the syntax, and now I can do that with JShell, perhaps a little bit quicker. So I'll skip that. I'll skip the slides on garbage first, because yesterday there was like a full hour talk by Kirk. But just be aware that garbage first is the default collector in Java 9, and if you've tuned GC before, then you will notice it because you're not using default flags. But if you have not, and like Kirk said yesterday, 70% of people don't really tune GC, they don't use any GC flags. Your behavior might change somewhat. And if you want to have details about that, go back to slides that will be published, I guess, by Kirk later on. We'll skip that. And list of you performance changes. So these are the changes primarily happening in the hotspot. So variable handles is the replacement for some of the issues, for some of the methods that are being used in some MESCON safe. Its ability to run safely and yet very performant, things like atomic cache and things like that. There are improvements in content and cache situations that are described in JEP143. JEP216 has more improvements on the completable futures, so I want to check that. Segment encode cache improves the data cache locality in ITLB misses, so it's a nice internal feature. It's important for people who care about performance. For everybody else, it's just there, it works. There is a new API to control JIT compiler, and there's a new JVM compiler interface. As you know, Oracle is building now a Java-based compiler, so a JIT that's written in Java, and they actually needed this interface, and so it's there. I'm sorry. There are optimizations on strings, notably a compact string optimization that allows you to that allows VM to store internally strings as Latin 8. So it should reduce the footprint. It's there on by default. All right. Some of you have been curious about how JVM works, and they do that by enabling various loggings, and those logins now conform a certain API. There are decorators and 6 levels of logging, and So you should be aware that these flags change if you use any logging for your for monitoring your production system. I should notice that the versioning of Java is changing. So, for example, this is on the left column. This is what you would get if you even do Java version, or when you query what's the version of Java that I'm running on, and it's changing to something on the right, which allows you to clearly distinguish between feature updates and security updates. And you might wonder where the syntax came from. It's something called semantic versioning. So just be aware of that. I probably don't have much time to go to talk about things that are going away, partly due to modularity. This is happening, and a couple of tools are going out. I will not go into much details about what's happening in the clients and security space, but if you could just read along these 6 JEPs, or feel free to ask about those during the Q&A section. And there are 4 security JEPs as well present in Java 9. And so what are we? We are a small company called Azul Systems. We built 2 products. One is called Zing. This is for Linux. It has a very efficient GC. We claim that we solved the GC problem altogether. But it also solves the warm-up problem by using something called persistent profile, which saves profile from one run to the other run and applies those to how JIT performs on the second run. And then there is a free distro of OpenJDK called Zulu that we ship along with installers. It's available for Windows, Linux, and Mac. 6, 7, and 8 that we do now. We have early access of 9 builds. We self-support. We provide these for free. These are available through your Linux repositories as well. So we are basically known for these 2 products that we do now. And one last thing. Unicode. There's a JEP that introduced support for Unicode 7 in Java 9, but Java 9 has delayed, and while it was being delayed, a new JEP came along and a new standard came along. That was Unicode 8. And you might wonder, well, what are the things that Unicode 8 covers? All languages have been addressed so far, but apparently now emicons are part of the Unicode, and even more so, you can actually have attributes to Unicode so that you can have different colors for emicons like that. So both Unicode 7 and 8 are coming into Java 9. And final closing. It's a work in progress. There will be breaking changes to many of the setups and environments. But ultimately, it's gonna be a better Java than it was before, and I'm fairly excited about it. But it will come with some cost and difficulties. And with that, I'm open for question and answer. Thank you.
We have time for a few questions.
So are they finally going to deprecate all the stuff that is, to eliminate all the stuff that has been deprecated since 1.1?
I'm sorry, say it again.
No.
I'm not sure I understand.
So are they going to finally remove all the stuff that has been deprecated since 1.1?
Is the deprecate side going away? I guess it's case by case. I can't give you a generic answer for that.
Any more questions?
Here's a question in the front row. So it's okay.
Do you know if there would be a way to modify the dependencies between modules by reflection or something?
Is there a way to modify dependencies? So yes, there will be runtime flags. So for example, you compiled those module S and P that I had in the example, but you did not declare a dependency, or you got them as as compiled ones. Is there a way to inject a dependency? Yes, there are 2 separate flags. that allow you to inject both, the export capability and the reading capabilities from the other side. So that is possible, but in order to do that, you need to control the environment which you are running. So in case let's say you're shipping a library and somebody else is doing the launcher, it can be a bit more problematic. So some people have been complaining about that, but yes, so there are flags that make it possible. Also, I mentioned that the class path, prepend class path option is going away. Some people ask, well, what do I do in order to inject my own implementation of, let's say, a standard class? And there's also a xpatch option, which allows you to to put a module with, let's say, your implementation of, I don't know, Java lang math on the top. So that class will be taken from that module that you supplied, and the rest is taken from your normal JDK. So that's how you would, let's say, experiment with the new implementation of a method or a class, and you use the rest. So class patch/p is basically being replaced by xpatch option, but it used to be on type by type, class by class basis. Now it's based on modules.
Thank you. Any more questions? No, thank you very much.